Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to start with your main module. Till now we have covered some basics of computers like what is input device, what is output device, what is input unit, what is output unit, what is memory, what is operating system. Then we have discussed what is Microsoft Office. That includes four parts, that is Word, MS Word 2010, MS Excel 2010, MS PowerPoint 2010 and MS Outlook 2010. We talked about in detail what is Word, what are the formatting tools available, what are the options available, and we have also discussed Excel in detail that is used for calculations purpose. That what is worksheet, what is a workbook. Then we also talked about PowerPoint in detail, like how to create a slide, how to create a PowerPoint presentation, what is a default extension, what are the views available in PowerPoint. Then we have also talked about Outlook, that is basically used for email purpose, for sending and receiving the emails. We have talked about how to create the email, how to schedule the meetings for the Outlook. So MS Word is basically used for documentation purpose, for writing anything, for creating the books, and MS Excel is used for calculation purpose. In the same way, PowerPoint is used for giving the presentation to the large number of audience. In the same way, Outlook is used for creating or sending and receiving the emails. Then we have also talked about some basics of internet in the last class. What is internet, what is www, what is web browser, what is web address, what is the syntax for web address. So all these concepts we have discussed till now, some basics. Today I am going to start with your main module, that is computer system. So let's see. This is the overview of your main module. This is your main module is divided into four semesters, four parts: semester 1, semester 2, semester 3 and semester 4. Semester 1 contains four topics, that is business skills for e-commerce, then computer system, then employability and professional development, then procedure programming. In semester 2 you have four topics: research skills, website designing, database design concept, office solution development. Then in the third semester, there are four topics: e-commerce strategy, web applications development, digital image creation and development, and then programming in Java. Then in semester 4, there are again four topics: information system in organization, quality system in IT, data analysis and design, then project designing, implementation and evaluation. These are the four semesters that is divided into four parts, and this is a 2-year program. So today I am going to start with semester 1. So this is your semester 1 starting. So today is your main day, main point of day where your semester 1 is starting, and I am going to start with the topic computer systems. The main target of this topic we have discussed, like Word, Excel, PowerPoint. So you have a brief knowledge of the computer. Today I am going to start with few basic concepts or introduction to the computer system. What is computer system, what is code, what is byte, some basics of the programming concept, because we have already covered some basics of the computer like Word, Excel, PowerPoint. So there is no, I think there is no hard and fast rule for giving an option or for giving the detailed version. In the same way, I am opting for the programming language, that is some basics of the computer system. So I am going to start with this topic, that is computer systems. So let's start. This is a book that is given by Pearson New International Edition, Computer System, A Programmer's Perspective, Randall E. Brand, David R. O'Halloran, 2nd edition. So this is the module name. These are the topics, these are the syllabus that is available for computer systems. This is the module syllabus, that is computer system book syllabus. The first is a tour of computer system, that is basics of computer system. Then representing and manipulating the information. That is how we can represent or how we can give detailed version of the information that is available in the computer. Then third topic is machine level representation of programs. That is how to create the program, what is machine level representation, what is machine level program. Fourth topic is processor architecture. Means what is the architecture for the processor, that is the CPU. What are the internal components like RAM chip, cache memory and so on. Then optimizing program performance. Then memory hierarchy. We have discussed primary, secondary. In this chapter we cover in detail what is programming language, what is memory, what are the types of memory. Then what is linking? Linking means how to link the program into the executable code. Then exceptional control flow. If there is an error, then how to control or how to give the exception so that error can be floated or error can flow from one place to the another place. Then ninth chapter is virtual memory. We will talk about virtual memory, what is virtual memory, what is the usage of virtual memory. Then 10th chapter is system level input output. Then concurrent programming. Then at last appendix, that is error handling, and then there are the references for the book. So let's start with first topic, that is a tour of computer system. In this there are multiple topics available. First is information is bits and context. Programs are translated by other program. It pays to understand how compilation system works. So let's start these topics in detail. These are the 10 topics which covered in chapter number 1. So let's start with first topic, a tour of computer system. First of all, introduction. This says a computer system consists of hardware and software that works together to run application program. So computer system is combination of the hardware and software that is mandatory for any program to run on the computer. So this is a combination, or computer system is a combination of hardware and software systems. Then specific implementation of systems change over time, but the underlying concept do not change. Means whenever we implement something or whenever we implement computer system, the concept remains the same, but the implementation that is platform will change. All computer systems have similar hardware and software components that perform similar functions. Programmers get better at their craft by understanding how these components work and how they affect the correctness and performance of their programs. You may learn practical skills such as how to avoid strange numerical errors. There are some numerical errors which are avoided using the programming language caused by the way that computer represent numbers. You may learn how to optimize your C code. So in this chapter we will study what is C language and how we can use the C language. You may learn how the compiler implement procedure calls and how to use this knowledge to avoid the security holes from buffer overflow vulnerabilities that plague network and internet software. This is how we can give the security to the computer. You may learn the promises and pitfalls of concurrency, a topic of increasing performance, increasing importance. In their classic context on the C programming, Kernighan and Ritchie introduced readers to C using the Hello program shown in figure 1. Although Hello is a very simple program. So this says Hello is a simple program that is written in C language, but for starting point of view, this is very important to know what is C programming and how we can write the simple programs in the C program. We begin our study of system by tracing the lifetime of the Hello program, from the time it is created until it runs on a system. So this chapter or this module start with some basic, that is C language, with some basic program, that is Hello program, that is how it is created and how it runs on the system. Then how to print the simple message and then terminate the message. As we follow the lifetime of the program, we will briefly introduce the key concepts, terminologies and components that come into the play. So this is the basic or the hello program in C language. This is the syntax. First of all, we have to write hash include, then there is a sign, then stdio.h. This first line is a header file. This says include the header file, that is standard input output. The full form of STIO is standard input output. .h means this is a header file. I am repeating again, this is a header line, this is the first line that shows the header. This includes, that is hash includes, means includes stdio.h, that is standard input output. The full form of STIO is standard input output.h. .h means this is a header file. Then starting with the main, this is the main function. This is a data type, that is int main. Then there is a parenthesis, this bracket is known as parenthesis. Then there is curly braces. This is a printf. So whenever we have to print anything on the screen, we have to write printf in the C language. Then there is a double quote, hello world. /n means print the next word to the next line. So /n is a tab escaper or escape tab which we can use for jumping to the next line. Then there is a curly braces closed. I am repeating again, this first line is a header file which shows that there are some standard input output. So these are the 4 lines that is written in the C language. First one is how to include the header file. How we can include the header file. Then there is a main function, that is we have started with the main function, that is we have started with the coding part. This is known as the coding part. Then there is a curly braces, that is open curly braces. Then we have to print on the screen, that is hello world. Then there is a closing curly braces so that we can close the coding. In the same way, the output is hello world. The output is hello world. Then there is a first topic, that is information is bits plus context. Means whenever we write any information, whenever we write any file that includes bits, that is 0 and 1, as well as the context that is written in the form of English statements. This says our hello programs begin life as a source program that the programmer creates with an editor. This means this code the programmer have to write on the editor. That is editor, that is C editor or Turbo C. There are so many editors available for writing the C programs that the programmer creates with an editor and save in a text file known as hello.c. So whenever we have to save the C language file, C language code, then we have to give the extension, that is .c. The source program is a sequence of bytes. This says the source program is a sequence of bytes, that is a sequence of 0 and 1 with the value of 0 and 1 organized in a 8-bit chunks. So whenever we combine 8 bits, that is known as the byte. Then each byte represents some text character in the program. Then most modern systems represent text character using the ASCII standard. Means whenever we have to represent some character, we have to use the ASCII standard. The ASCII full form is American Standard Code for Information Interchange. I'm repeating again, American Standard Code for Information Interchange. Standard that represent each character with a unique byte-sized integer value. Means whenever we have to write some program that must be converted into the ASCII code, that is American Standard Code for Information Interchange. For example, figure show the ASCII representation of the hello.c program. Now let's see figure 2. This is a figure 2. This is hash include, then there is a space, there is a symbol, then stdio dot h. So whenever we have to write some program in C that have some ASCII code, like hash have ASCII code. This is a predefined standard ASCII code. We cannot change the ASCII codes. These are the predefined that is available in the computer. So hash have a ASCII code 35. In the same way, I is 105, 110, 99, 108, and so on. There is a ASCII code for space also. There is a ASCII code that is known as the 32. Then there are multiple ASCII codes. Don't have ASCII code 46, H, 104, /n, 10, 10, space 32, and so on. Even brackets have ASCII code. Means each and every individual character symbol have a ASCII code in the computer language. Then this says the hello.c program is stored in a file as a sequence of bytes. Each byte has an integer value that corresponds to the same character. For example, the first byte has an integer value 35, which represents the character hash. As I told you, hash have a ASCII value that is 35. The second byte have a 105, that is I, and so on. Notice that each text line is terminated by the invisible new line character. Means whenever we have to terminate, whenever we have to put the output in the next line, we have to use the /n character. That is a new line, which is represented by the 10 value. Files such as hello.c that consist exclusively of ASCII characters are known as the text file. So whenever we will write ASCII code, that is known as the text file. So text file is the file that contains only the ASCII characters. All other files are known as the binary file. So there is a difference between the binary file and the text file. Binary file may include number, integer, text, but ASCII character file is known as always the text file. So text file is a file that contains only ASCII characters. Binary files are the file that contains number, symbols, text, and etc. That is extra. Then next paragraph is the representation of hello.c illustrates a fundamental idea that include disk files, programs stored in memory, user data stored in memory, represented as a bunch of bits. The only thing that distinguishes different objects is the context in which we can view them. For example, in different contexts, the same sequence of bytes might represent an integer, floating point, character string, or the machine instruction. This is the ASCII text representation of hello.c. Then there is some fundamental concepts of the C programming language. As we have written the code in C programming language, so let's talk about some brief overview of the C programming language. First of all, what is a programming language? Programming language is nothing, the language which the programmer uses. Then what is a language? The language is the way to communicate. For example, the way we communicate is either using the English or the Hindi. As an Indian, I may use or I can use Hindi also. So this is a way of communication that we can communicate with each other by way of the talking. In the same way, programmers can communicate with each other by using the programming language. So if a programmer writes some code, then the programmer have to use some programming language. So in simple terms, a programming language is the language which the programmer uses for writing the programs. Then there are multiple types of programming language. One of the type is C programming language. So now let's see what is C programming language. This says C was developed from 1969 to 1973 by Dennis Ritchie of Bell Laboratories. Means this is the person name which developed the C language. These are the years. Means first of all starting with 1969, then there is some improvement, there is some achievement, then goes to the 1970, 1971, 72, and then at last finalized in 1973 of Bell Laboratory. Means Dennis Ritchie belongs to the Bell Laboratory. The American National Standard Institute, that is ANSI. So ANSI full form is American National Standard Institute, rectified the ANSI C standard in 1989. Means Dennis Ritchie have built in 1973, but it is rectified by ANSI in 1989. And this standardization later became the responsibility of the ISO, that is International Standard Organization. The standards define the C language and a set of library functions that are known as a C standard library. Kernighan and Ritchie describe ANSI in their classic books, which is known efficiently as K and R. So these are the two persons which describe the ANSI scheme. In Ritchie's word, C is quirky, flawed, and enormous success. So why the success? These are the multiple reasons why C programming is a popular programming language and why it is known as the enormous success, that is without any errors. So these are the multiple features of the C programming language. These are the three features. First one is C was closely tied with the Unix operating system. As I told you, there are multiple types of operating system which interact with the hardware, or which interact with the user, or which use as an interface between the user and the hardware. So C was closely tied with Unix operating system. This says C was developed from the beginning as the system programming language for Unix. Means Unix operating system is also built up by using the C language. Most of the Unix kernel and all of its supporting tools and libraries were written in the C language. As Unix became popular in universities in the late 1970s and early 1980s, many people were exposed to C and found that they liked it. Since Unix was written almost entirely in C, this says entirely in C, almost, means not exact but almost, that is 99% it is written in C. It could be easily ported to the new machine. Means whenever I have to write, or whenever I have to write the programming language, that is C language code, into any machine, that is Unix machine, Linux machine, so I can easily port to the new machines, which created an even wider audience for both C and Unix. So this means we can use any machine for writing the C programming language which have an operating system Unix. This is the one of the feature of the C language. Next is C is a small, simple language. Means the designing part of the C is not hi-fi or is not huge. It is very small and the simple language which is controlled by the single person rather than the committee. Means it is handled or it is controlled by only the single individual. This is the design was controlled by a single person rather than a committee, and the result was a clean, consistent design with a little baggage. The K and R books describe the complete language and the standard library with numerous examples and exercises in only 261 pages. The simplicity of C made it relatively easy to learn and to port to the different computers. So C is very simple language and the portable language and the small language which can easily be handled or easily be understandable by the multiple users. Then next point is C was designed for a practical purpose. This says C was designed to implement the Unix operating system. Later other people found that they could write the programs they wanted without the language getting in the way. These are the multiple features of the C programming language. Then next topic is programs are translated by other programs into different forms. The Hello programs begin life cycle as a high-level C program, but it can be read and understood by human beings in that forms. However, in order to run hello.c on the system, the individual C statement must be translated by other programs into a sequence of low-level program machine language instructions. So whenever we have to write or we have to compile the C language program, so we have to use multiple machine language instructions so that these language code or C language code is easily interpreted and converted into the bits or the 0-1 form. These instructions are then packed into a form that is known as the executable object program and stored as a binary disk file. Object programs are also referred as the executable object files. On a Unix system, the translation from source file to object file is performed by the compiler driver. So whenever we have to compile or whenever we have to translate the source file into the object file, that is executable object file, that is compiled by the or that is performed by the driver that is known as compiler driver. This is a code gcc-o hello.c. This is the main syntax or main diagram for the compilation purpose. Figure 3 is the compilation system. This is the main crux or this is the main diagram which covers all the concepts of the C language. So let's start in a simple terms, in a brief way, what is the compilation system. First of all, this is the program. This is our program, that is hello.c. This is source program. Then there is a preprocessor, CPP. So whenever hello.c is going into the preprocessor, that is converted into the hello.i. So this the arrow, see the arrow. First of all, hello.c goes to the preprocessor, that converted into the hello.i. This says modified source program, that is text. Then hello.i is going to the compiler, that is CC1. Then automatically it converted into the hello.s, that is assembly program. First of all, .c is converted into .i, then .i is converted into .s. Then .s is going to the assembler, that is AS. Then it converted into the O, that is relocatable object program, that is in binary form, that is 0 and 1. Then hello.o is going into the linker, that is LD, linker. Then it automatically comes into the hello part, that is executable object program. I'm repeating again. First of all, hello.c is going into the preprocessor, that is converted into the hello.i. Then hello.i is going to the compiler, that is converted into the hello.s. Then hello.s is going into the assembler, that is converted into hello.o. Then hello.o is going to the linker, that converts the program into the executable object program, that is only the hello. So these are the multiple parts or multiple sub-programs that is covered whenever we have to write the program, that is hello.c, and that is converted into the hello. These are the multiple sub-programs or multiple sub-parts. This says here the GCC compiler driver reads the source file, that is hello.c, and translates into an executable object file, that is hello. So compiler reads hello.c and translates into the hello. The translation is performed in the sequence of 4 phases. So starting with this one, ending with this one. This contains 4 phases. that is preprocessor, compiler, assembler, linker, and are collectively known as the compilation system. So if a question comes that what is the 4 phases that comes in the compilation system, so the answer is first one is preprocessor, then compiler, then assembler, and then at last linker. Now let's see in detail what is preprocessing phase, what is compilation phase, what is assembling phase, and what is linking phase. First one is preprocessing phase, that is this one. The preprocessor in bracket there is a CPP modifies the original C program. Original C program is hello.c according to directives that begin with the hash character. For example, hash include stdio command in line 1 of hello.c tells the preprocessor to read the content of the system header file, that is stdio.h, and insert it directly into the program text. The result is another C program, typically with the I suffix. So whenever we compile or whenever we insert the hello.c into the preprocessor, that is converted into the hello.i. Then there is a compilation phase, that is CC1 translates the text file hello.i, that is hello.i, into text file, that is hello.s, which contains an assembly language program. This is the assembly language program and this is hello.h. Each statement in assembly language program exactly describes one low-level machine language instruction in a standard text form. Assembly language is useful because it provides a common output language for different compilers for different high-level languages. For example, C compilers and Fortran compilers both generate output files in same assembly language. So compilation phase converts the program that is hello.i into the text file that contains the assembly, that is hello.s. Then next phase is assembly phase. Next, the assembler AS converts hello.h into the machine language instructions, packages them into a form known as the relocatable object program, and stores the result into the object file, that is hello.o. So assembly phase converts hello.s into the hello.o. Next line says the hello.o file is a binary file whose byte encodes machine language instructions rather than the characters. If you were to view hello.ho with a text editor, it would appear to be gibberish, means there is no character, there are hodgepodge characters. Then at last there is a phase, there is a linking phase. This says, notice that our hello program calls the printf function, which is a part of standard C library provided by every C compiler. So this is the linking phase which converts into the hello, that is into the executable program file. The printf function resides in a separate predefined object file known as printf.o, which must show somehow merged with our hello.o program. The linker, that is LD, handles this merging. The result is hello file, which is the executable object file. So the output is, after linking, the output is only hello, which is the executable object program or object file that is ready to be loaded into the memory and executed by the system. This is the phase how C programming language or C syntax or the C program is going into the preprocessor, converted into the .i, then converted into the .s, then converted into .o, and then at last converted into the executable program, that is hello. This is the compilation system, compilation phase that converts the C language into the executable programming language, the executable object program. Next is, third point is it pays to understand how compilation system work. For simple programs such as hello.c, we can rely on the compilation system to produce correct and efficient machine code. However, there are some important reasons why programmer needs to understand how compilation system works. So these are the few topics, or these are the few advantages, few benefits that is available, how compilation system works, or what are the benefits then what programmer uses or understand how compilation system works. So these are the multiple advantages or benefits whenever we compile the program, so that programmer can understand. First advantage is optimizing program performance. Optimization means fully efficient, or these are the fully good source code that C language uses. So this is optimizing program performance, means enhances the program performance. So whenever we write the C programming language and we are using compiler for compiling the program, so automatically the performance for the program increases, or performance for the program enhances. However, in order to make good coding decision in our C program, we do need a basic understanding of the machine level code and how the compiler translates different C language into the machine code. For example, means for writing the easy or for writing the good C programs, we have to translate different C statements into the machine codes. For example, is a switch statement always more efficient than a sequence of if-else statements? These are the multiple statements which we have covered in detail. Next advantage is that it understands linked line errors, meaning whenever there is any error in the compilation phase, it has to be stopped or it has to be rectified in that phase only. For example, if error comes in preprocessor phase, then automatically or then by default the compilation phase or the linking error will be removed at the preprocessor phase only. So this is, in our experience, some of the most perplexing programming errors are related to the operations of the linker, means the maximum error found at the linking phase, especially when you are trying to build large software system. For example, what does it mean when the linker reports that it cannot resolve a reference? What happens if you define two global variables in different C files with the same name? So these are the multiple advantages which compilation phase or uses, or which compilation phase gives, that is understanding the link time error that is available while linking while loading the programs. Then next advantage is that it avoids or avoiding security holes. There are multiple security holes in the C language, and these security holes are avoided by the compilation phase or by the compiler or the compilation system. This says for many years buffer overflow vulnerabilities have accounted for the majority of security holes in network and internet servers. These vulnerabilities exist because too few programmers understand the need to carefully restrict the quantity and forms of data they accept from untrusted sources. Means before or when we are writing the C programming language, there are some security loopholes that occur while writing the C programs, because the programmer cannot hide or cannot see the unauthorized access or unauthorized user, because they have an authority or they have a need to go and accept from the unauthorized sources also. A first step in securing programming is to understand consequences of the way data and control information are stored on the program stack. So these are the multiple options, these are the multiple benefits that is uses when we are using the compilation system. Next is processor read and interpret instructions in memory. This is processors means CPU read and interpret instructions that is stored in the memory. So till now we have discussed what is a programming language, what is a C language, what is a compilation phase, and what is the compilation that is used in the C language. Next topic is processors read and interpret instructions stored in memory. So let's take 5 to 10 minutes break and then come back, then starting with the fourth topic, that is processor read and interpret instructions. So let's take 5 to 10 minutes break. Now let's start with the fourth topic, that is processors read and interpret instructions stored in memory. As the name advises, processors, that is CPU, how CPU reads and interprets instructions that is stored in the memory. This is, at this point, our hello.c source program has been translated by the compilation system into an executable object file that is known as the hello. As I showed you in the figure, hello.c program is converted with the use of compilation system into an executable object file that is hello, that is stored on the disk. To run the executable file on a Unix system, we type its name to an application program known as the shell. This is how we can type the program name by using the shell, that is unix./hello, hello world, Unix, and then Unix closed. The shell is a command line interpreter. This is one of the important lines. A shell is a command line interpreter that prints a prompt, waits for you to type a command line, and then performs a command. So this is how we can give the command. It is a command line interpreter that prints a prompt, that this is a prompt, single line. This is a prompt. This one is a prompt. And then waits for the type to print on a command line and then performs a command. So this is how we can give the command, or how we can use the command. If the first word of the command line does not correspond to a built-in shell command, then the shell assumes that it is the name of an executable file that it should load and run. So in this case, the shell loads and runs the hello program and then waits for it to terminate. This is the syntax, or this is the shell programming. So we can terminate, or we can load, or we can give the hello program and then wait for the termination. The hello program prints its message to the screen and then terminates. The shell then prints a prompt and then waits for the next input command line. This is how we can give the commands. Then 4.1 is hardware organization of a system. Till now we have covered how the compilation system converts the hello.c into the hello. That is how the C programming language code is converted into the executable object program. Now let's see what is the hardware organization or hardware implementation of a system. This says, to understand what happens to our hello program when we run it, we need to understand the hardware organization, means hardware implementation of a typical system, which is shown in figure 4. This particular picture is modeled after the family of Intel Pentium. This is the figure 4, hardware organization of a typical system, that is CPU, as I told you, central processing unit, ALU, arithmetic and logical unit, PC, that is program counter, and then there is a USB, that is universal serial bus. This is the main diagram. Now let's see one by one. This is the CPU diagram. First of all, CPU. There is a one name, that is PC, that is a program counter. There is a register file. These are the multiple register file. There is a concept ALU, that is arithmetic and logical unit, that is used for calculation purpose. There are multiple lines, like ALU interact with the registers and registers give the output to the ALU. So first of all, input comes, ALU performs the operation, and then output stored in the register. Then there is a bus interface. This is a bus interface. There is a system bus. System bus means a line from which the data travel from one place to the another place. There is the input output bridge. This is the bridge that acts like a mediator between the system bus and the memory bus. So this is lies in between the system bus and the memory bus. And input output bridge is communicated with the main memory with the help of the memory bus. So this is the first part. First of all, CPU, there are multiple parts like a register file that interacts with the ALU. There is a bus interface which interacts with the input output bridge as well as the register file. And input output bridge is like a mediator between the system bus and the memory bus. And input output bridge is always communicated with the main memory with the help of the memory bus. Then next line is, this is the next line. There is the input, this is the input output bus that connects with the input output bridge. There is a USB controller. This is a USB controller like mouse, keyboard controller. There is a graphic adapter that is used for display. There is the disk controller that is used for storing purpose. This is the disk. Hello executable stored on the disk. This is the expansion slots so that we can expand it. Suppose these are the three concepts, or these are the three slots that is available on the input output bus, like disk controller, graphic adapter and USB controller. You can easily modify or you can easily increase this expansion slot by using the expansion slot that is available. Means you can simply connect or you can easily connect to the input output bus by using the expansion slot. So whenever I want to connect a new device to the input output bus, I can open these expansion slots so that new devices, new input can be attached to the input output bus very easily and quickly. So this is how the hardware organization of a typical system. So this is the internal part of a typical system. These are the multiple parts that is available in a system. We simply see on the system, then simply start the system, but that is not only the concept. This is the concept that is like in the system. This is the hardware implementation or hardware organization of a system. Hardware organization means what is the hardware components or how hardware components are tackled or how hardware components are attached within a system. Then now let's see one by one. There is a buses. Buses means that communicate, that uses as an interface for the communication. This says running throughout the system is a collection of electrical conducts known as the buses that carry, as I told you, that transports bytes of information back and forth between the components. This is the way of communication. Bus is the way of communication through which we can travel the bytes or carry the bytes from one place to the another, that is back and forth between the components. Buses are typically designed to transfer fixed size chunks of bytes known as the words. So buses are used to transfer the byte, that is chunks of byte, that is known as words. The number of bytes in a word, the word size, is a fundamental system parameter that varies across systems. Most machines today have word sizes of either 4 bytes. 4 bytes means 1 byte equals to 8 bits, so 4 bytes is 32 bytes. Or 8 bytes, that is 64 bytes. For the sake of our discussion here, we will assume a word byte of 4 bytes and we will assume that buses transfer only one word at a time. Then, the crux of this paragraph is that buses are used for communication, or buses are used to carry bytes, that is word, from one component to the another component. Then next one is input-output devices, that is I/O devices. Input-output devices are the system connection to the external world. So whenever we have to connect to the external environment, that is done by the input-output devices. Our example system has 4 input-output devices, that is keyboard, mouse for user input, display for user output, and disk drive for storage of data and programs. Initially, the executable hello program resides on the disk. Then each input-output device is connected to the input-output bus by either a controller or an adapter. Means each input-output device, this is the input-output device, this is the input-output bus, is attached to either compiler or either controller or the adapter. The main difference is the packaging difference. Then next is your main memory. As I told you in the previous classes, main memory is basically used for storing the programs and the data. This says it is a temporary storage device that holds both a program and the data it manipulates while the processor is executing the program. So the meaning of this line is that the main memory is nothing but the temporary storage area that holds both the programs and the data that it manipulates while the processor is executing the program. So whenever CPU is executing the program, main memory is a device or the temporary storage where the data and program is handled and it can manipulate while the processor is executing the program. Physically, main memory consists of a collection of dynamic random access memory chips, that is DRAM. So I told you in the previous classes, main memory is divided into two parts, that is static and dynamic. And static memory is which cannot be changed, and dynamic means which can be changed on a regular basis. Logically, memory is organized as a linear array of bytes, each with its own unique address, starting at 0. In general, each of the machine instructions that constitutes a program can consist of a variable number of bytes. The sizes of data items that correspond to the C program variable vary on the type. Next is your processor. So till now we have covered input, output, main memory. Now what is a processor? This is the CPU or simply processor. Means that another name for processor is CPU. So processor is nothing but the CPU, that is central processing unit, is the engine that interprets or executes instructions stored in the memory. As at its core is a word-sized storage device known as a program counter. At any point in time, the PC points at the contains the address of some machine language instruction in main memory. So CPU is nothing but an engine that stores the program, that executes the program that is stored in the main memory. So CPU is nothing but like a brain of the computer system. Its main task is to execute the program that is stored in the main memory. Next is, there are only a few of these simple operations and they involve around the main memory, the register file and the ALU. So CPU contains three multiple operations that revolve around the main memory, register file and the arithmetic and logical unit. The register file is a small storage device that consists of collection of word-sized registers, each with its unique name. The ALU computes new data and address value. PC is known as the personal computer. These are the multiple operations that is executed by the CPU, like load. First of all, loads the content into the memory, then store, then operate, and then jump. So these are the multiple operations that is performed inside the CPU. First of all, it loads into the main memory, it's stored into the main memory, then it operates. Operate means execute with the help of ALU, then it jump with the help of the PC, that is program counter. 4.2 is running the hello program. Till now we have discussed what are the multiple parts, what is the hardware implementation of the program, hardware organization of the program. The next topic is running the hello program. How we can run? We can run using the DMA, that is direct memory access. Now let's see with the help of diagram. This is the diagram, reading the hello command from the keyboard. These are the multiple diagrams that is available. This is loading. This is writing the output. So let's take, given this sample view of system hardware organization and operation, we can begin to understand what happens when we run our example program. We must omit a lot of detail here that will be filled in later, but for now we will content with the big picture. Initially, the shell program as I told you, shell program is a command-like interpreter which behaves like the mediator between the shell and the program. Initially, the shell program is executing its instructions, waiting for us to type a command. As we type the characters like /hello at the keyboard, the shell program reads each one into the register and then stores in the memory. When we hit the enter key, means after typing this one, when we hit the enter key, the shell knows that we have finished typing the command. The shell then loads the executable hello file by executing a sequence of instructions that copies the code and data in the hello object file from disk into the main memory. Means whenever we press the enter key, then automatically shell loads the executable hello file by executing the instructions that copies the data and the code into the hello object file into the main memory. The data also includes the string of characters, that is hello world /n, that will eventually be printed out. Using a technique known as direct memory access, the data travels directly from disk to the main memory without passing through the processor. Next is, once the source and the code and the data in object file are loaded into the memory, the processor begins executing the machine language instruction in the hello main module or main routine. So this is once the data and the code, means once the data and the code is entered into the hello object file that is loaded into the memory. The next step is that the processor begins executing the machine language instructions in the hello main routine. These instructions copies the byte into the hello world string from memory into the register file and from here to the display device where they are displayed on the screen. This is shown in step of figure 7. Now let's see figure 5. Figure 5 is reading the hello command from the keyboard. The same scenario, CPU, PC, that is program counter, register file, ALU. There are multiple new arrows that is arrived. This is system bus, the same, main memory. This is the bus interface, means we can give the input output from the registers also. Here this line shows that the input is going to the main memory, or input is taken from the registers and the output is gone to the main memory, or vice versa. So these are the two arrows. One is used for input and another is used for giving the output. There is a new line, that is USB controller. So input output means we can give the input to the USB controller with the help of this is known as the universal serial bus. We can give the input to the USB controller. This is a mouse keyboard. User types hello with the help of the keyboard, and this hello will go to will come from the input output bridge. This is the graphical adapter. There is a display. Then there is a disk controller that is used for storing purpose, expansion slots for other devices such as network adapters. So this is the diagram how we read the hello command from the keyboard. Keyboard is available over here. First of all, user types the word hello. This goes to the input output bridge. that transfer to the register file. This register file transfer to the main memory. This is how we can flow the task. I'm repeating again. Whenever user types the hello, this goes to the input output bridge with the help of this line. Then it goes to the register. CPU processes the task. Then it goes to the main memory for storing purpose. Next, figure 6 is how we can load the executable from disk into the main memory. In the same way, whenever we use a keyboard, there is a new line, and now how we can load the executable files into the main memory. This is the disk controller. A new line is coming from the disk controller, and we can fetch the data from the disk controller, or we can load the executable from disk into the main memory. First of all, the data will come from here to the here. So first of all, the data will gone from the disk controller to the input output bridge. Then input output bridge stores the data into the main memory by using the memory bus. So this is hello executable stored on the disk that goes to the input output bridge, that goes to the main memory. That comes hello world, that is hello code. This is how we can load the executable from the disk to the main memory. All other concepts are same, CPU, system bus, but the new line came that is used for disk controller to the main memory. Next, figure 7 is writing the output string from the memory to the display. Means how to write the output string from the memory to for the displaying purpose. First of all, this is used for display graphics editor, then display hello world. First of all, this will go to the input output. This is the multiple lines, main memory, graphics editor. First of all, main memory line is goes to the register file, then register file is go to the input output bridge, the input output bridge line go to the graphic editor. I'm repeating again. First of all, main memory that have a data hello world is gone to the input output bridge to the bus interface, that goes to the register file. Then with the help of register file that came to the input output bridge and then came to the graphic editor for displaying the hello world. So these are the multiple commands that we can use for writing the program. I think today it's too heavy or too much for the starting point of view. So let's finish over here only. But before this, let's take a quick review what we have covered today. And if you have any doubts, then please clear today only, because I think it's too hectic. So let's stop over here only. But before this, let's take quick review. We have started with what is computer system, that consists of hardware and software that works to run the application programs. Then what is the computer system that is available for writing the programs. Then we used what is C language, what is C programming language, how we can write the programs, that is hello program. This is the main syntax for the program hello C program, that is hash include stdio.h, int main, printf hello world, that is used for printing. Then we have covered what is information, then includes bits and the context. These are the ASCII code for different C programming code, that is hash include stdio.hash. Hash has a different ASCII code, space has a different ASCII code, stdio has a different ASCII code. Means each character, each symbol have a different ASCII code, that is American Standard Code for Information Interchange. Then we have studied what is C programming, that is developed by the Dennis Ritchie. These are the multiple advantages or multiple features of the C programming. That is, C was closely tied with the Unix operating system. C is a small language or the simple language, and C was designed for a practical purpose. Then we also covered how programs are translated from one form to the another form by using the compilation system, by using the compilation driver. This is the compilation system. Hello.c is converted into the hello by these four phases, that is preprocessor, compiler, assembler and linker. First of all, hello.c is converted into the hello.i. Then hello.i is converted into the hello.s. Then hello.s is converted into the hello.o. Then hello.o is converted into the executable object program, that is hello. Then we have discussed in detail what is preprocessing phase, what is compilation phase, what is assembly phase, and what is linking phase. Then we have also covered how it pays to understand how compilation system works. Means what are the benefits or what are the advantages of compilation system or benefits of the compilation system. These are the multiple benefits, like it helps to optimize program performance. Understanding the link time errors, avoiding the security holes. Then we have also covered how processor reads and interprets instructions stored in the memory. Shell is a program that used for the printer or that prints a prompt and then waits for the writing the program. Then we have covered what is the hardware organization of a system. This is the hardware organization. And then talked about different concepts like buses, input-output devices, main memory, processor. Then how to run the hello program. There are multiple concepts how we can run the hello programs. First of all, reading the hello command from the keyboard. There are multiple lines which shows how we can write the program. Then how to load the executable from disk into the main memory. Then how to write the output from the memory. So these are the four topics which we have covered yesterday. I think this is the first class, so I'm not taking too much, so it's not heavy for you. But before this, before coming to the next class, that is tomorrow's class, please take a quick review or quick recap of these four topics so that I can start with the next topic tomorrow and you are able to understand each and every concept. So let's stop over here only. But before coming to the next class, please read all the four topics so that I am easily able to understand or you are easily able to understand the concepts. So let's stop here only. Thank you so much for listening me patiently and very carefully. So if you have any doubts, then please text the doubt and I will answer it. And in tomorrow's class, I am continuing with topic 5, that is caches matter. So thank you so much everyone. We will meet tomorrow with the new topics, that is starting with topic number